Good morning, students. I am Dr. S. J. Suryavanshi, Head Department of Zoology, Chhatrapati Shivaji Mahadhyalaya, Srigonda. FYBSc semester first, Zoology paper first, Animal Diversity first. We will continue the chapter number 5, phylum Porifera, and the subpoint is the skeleton in sponges. Like other animals, sponges through their primitive possesses skeleton that gives their bodies shapes and structure. The sponges inhabitant of the deep sea have pseudoskeleton composed entirely of foreign bodies without any element secreted by the sponge itself. The vast majority of sponges, however, possesses a true skeleton called as the autoskeleton, composed of elements secreted by the sponge itself. Type of skeleton in sponges. All the sponges have a skeleton. Their skeleton is embedded in the mesenchyme. Skeleton composed of separate spicules or interlacing sponging fibers or both parts of the sponges. Skeleton also serves as the basis of classification of the sponges into various classes like Calcarea, Hexactinellida, and the Desmospongia. Spicules. These are structure of spicules. Spicules are microscopic crystalline structure. This gives the sponge their shape, rigidity, and form. Spicules consist of spine or a ridge that radiate from a point. The spicules are secreted by spherical mesenchymal amoebocytes called as the scleroblast cell. The calcareous spicules are secreted by special type of cells called as sclerocytes. These sclerocytes are derived from binucleated mesenchymal scleroblasts. Type of spicules. On the basis of type of deposit on core organic matter. All kinds of spicules have a core of organic materials around which either colloidal silica or the calcium carbonate is deposited. On deposit of organic matter, basis of spicules are of two types. Calcareous spicules, organic material in this type of spicules is the calcium carbonate or calcite, observed in sponges of class Calcarea. Siliceous spicules are formed with organic colloidal silica or silicon. Sponges of classes Hexactinellida have siliceous spicules. On the basis of size and function, spicules may be small or large in size. These spicules are of following two types: microsclerous and megasclerous. Microsclerous, these are thin. These are small spicules occurring interstitially. Microsclerous are small spicules measuring from 10 to 60 micrometer and are scattered throughout the tissue and are not part of the main support element. This is the diagrams showing the different structures of microsclerous. Type of microsclerous: Anisochilus, chili, Eustace, forceps, Isochilus, Microstrongyls, Oggias, Oggesters, Sigmas, Spirasters. Second one is the megasclerous. These are larger spicule constituting skeleton of spongy body. Megasclerous are large spicules measuring from 60 to 2000 micrometer and offer function as the main support elements in the skeleton. Type of megasclerous: Acanthostyles, Trianus, Strongylis, Styles, Tornotes, Tylotes. This is the different types of the megasclerous showing in the diagrams. On the basis of number of axes and rays, spicules may occur in various forms like the simple rod or in the form of forks, anchors, shovels, stars, plumes, etc. The spicules forms depend on the presence of number of axes and rays. These spicules can be divided into the following forms: monoaxon, they may be straight needle-like or a rod-like, or may be curved. Their ends may be pointed or hooked or knobbed. Monoaxons can be both calcareous and siliceous type. Monactinal growth of the spicules takes place only in one direction. Diactinal, the growth of the spicules takes place in both direction. Triaxon, the spicules have three axes that cross one another at right angles to produce six rays. Thus, it is called as the hexagonal spicules. Tetraxon, the spicules have four rays, each pointing in different direction. Usually, one of the four rays is elongated, giving the appearance of a crown of three rays. Such spicules are called as the trianes. Next one is the polyaxon. These are the spicules with several equal rays radiating from a central point. They may be grouped to give star-like appearance. Polyaxon spicules are found along with the microscleras. Different monoaxon, triaxon and the tetraxon spicules in the figures. Monoaxon spicules, monoaxon, diagonal monoaxon, curved monoaxon. Amphidisc. If the elongated ray bears a disc at both ends, it is called as the amphidisc. Calthrops. Sometimes all the rays are equal. When all the rays are equal, it is termed as the calthrops. Triradiate. Sometimes one of the rays is lost, and then it is known as the triradiate. These triradiate rays are the characteristic of calcareous sponges. Quadriradiate. When all the four rays persist, it is called as the tetraradiate or the quadriradiate. Polyaxon, amphidisc, calthrops and the triradiate. Then the second part of the skeleton is the spongin fiber. Structure of the spongin. Spongin is a scleroprotein containing sulfur and chemically related to the collagen. It also contains large amount of iodine. It is insoluble in water and chemically resistant to protein digestive enzymes. Spongin is an organic, horny, elastic substance which resembles silk in chemical composition. Spongin fibers are fine threads consisting of a soft granular axial core externally surrounded by concentric layers of spongin. Because of presence of large amount of iodine, in olden days the bath sponge was used to cure for croup, a throat condition in children resulting from inflammation and partial obstruction of larynx. In the class Desmospongia, sponging fibers occurs in various forms. It may occur as a cement connecting together siliceous spicules. It may be found in the form of branching fiber in which siliceous spicules are embedded. This is the diagram of spongin fibers. Thank you.